Hello everybody. Today is another day, and in the last video we had the instruction to the compiler linker and libraries, the 0.5, and then 6 and 7 installing integrated development environment IDE and compiling your first program, the Hello World program. And now we continue with the next file, a few common C++ problems, and that's what we do or start today. And I would say let's do it. Before I start, like always, this website is free to use for everyone and is ad-based, so it is sponsored by ads. So if you use it, turn on your ads so the website will be supported and can be maintained by Alex, that is supporting this website, or most of the articles are made by Alex here. And yeah, you can help him out just like that, or you can even donate him at the donate button. And with that, maybe you see I don't have ads, and this is because I'm making the video with it, but if I use it normally, I turn the ads on and support Alex with him, and I suggest you to do that too. And now we can start. 0.8, a few common C++ problems. In this section, we will address some of the common issues that new programmers seem to run across with fairly high probability. This is not meant to be a comprehensive list of compilation or execution problems, but rather a pragmatic list of solutions to very basic issues. If you have any suggestions for other issues that might be added to this list, post them in the comment section below. General runtime issues. When executing a program, the console window blinks and then closes immediately. First, add to ensure following lines are near the top of your program. Visual Studio users, make sure these lines appear after include pch.h or include stdafx.h if those exist. And then you have to include those two and the program under that. We already did that yesterday for the ones that hadn't working IDE, so it's basically a repetition. Second, add the following code to the end of your main function right before the return statement, like I showed in the last video. This will cause your program to wait for the user to press a key before continuing, which will give you time to examine your program output before your operating system closes the console window. Like we did, we had to press 2 times on the enter button and then it closed again. Other solutions, such as the commonly suggested system pause solution, may only work on certain operating systems and should be avoided. So only use them if you really know it works on your operating system. Other versions of Visual Studio may not pause when the program is run in Start with Debug F5 mode. Try running in Start Debug by Ctrl F5 mode. We could try this quickly. For me, when I click F5, it compiles or it debugs, and we can try Ctrl F5 and it makes the short debug. So it debugs or it starts without debugging. And like you see, it's here in little window. Ctrl plus F5 is start without debugging, and the other one is just debugging and is available with F5 in Visual Studios. And now I ran my program and get a window, but no output. Your virus scanner or anti-malware may be blocking execution. Try disabling temporarily and see if that's the issue. You can try that. And my program compiles, but it isn't working correctly. What do I do? Debug it. There are tips on how to diagnose and debug your programs later in chapter 3. So if the debug doesn't work, for example, I can simulate that. If we, for example, put away the semicolon, we get an error because it has no end. And when we want to debug it, it gives us an error, and then expected a semicolon, at line 9, and you can look at line 9. There is no error for a semicolon here, but you know we deleted it here because you have to go to the previous code and look if the error could be at the line before it, because the program looks it like that the return is directly behind the sentence. And with that we can just replace the semicolon again, and our program works fine again. So, and now we can continue. And general compile time issues. When I compile my program, I get an error about unresolved external symbol main or winmain16. This means your compiler can't find your main function. All programs must include a main function. There are a few things to check. Does your code include a function named main? Is main spelled correctly? When you compile your program, do you see the file that contains function main get compiled? If not, either move the main function to one that is, or add the file to your project. See the lesson 2.8 programs with multiple code files for more information about how to do this. Did you create a console project? Try to create a new console project. And here I can show you this. This here is the main function, integer and main, and without a semicolon. And when you have all inside here, it should work without a problem. And if it doesn't work and you have it exactly like that, try to make a new project, start a new Visual Studios, try it again, and if it still doesn't work, try to fix it or go to chapter 3 to search what error it could be. And then I quickly want to check if my recordings really started. Yes, they did. And now we can go to the next question. I'm trying to use C++ 11, 14, 17, XX functionality, and it doesn't work. If your compiler is old, it may not support these more recent additions to the language. In that case, upgrade your compiler. For modern IDEs, compilers, your compiler may be defaulting to another language standard. We cover how to change your language standard in lesson 0.12. Configuring your compiler, choosing a language standard. I just quickly show it so you understand it. We have here properties, and then in here we will show this later how this all works. We have here different standards, and as you can see, we have here in general, should it be? No. In where is it? Somewhere is the I also have to search it by myself. I thought it was here. In general. Ah, yes, here. By default, we have ISO C++ 14, and he recommended us to have C++ 17, and you can choose them here. But I leave it for the example on C++ 14, so we can change it later to C++ 17 or higher. And now we can go back to the next question. When trying to use sin, count, or endl, the compiler says sin, count, or endl is an undeclared identifier. First, make sure you have included the following line near the top of your file. / include iostream, because that's the library you want to access to have access to the sin, the count, and the endl. This is called the standard library, like it says in the second. Second, make sure each use of sin, count, and endl are prefixed by std double point. For example, std double point, a double point, count hello world std double point endl, semicolon. And you have to do that the compiler knows this here is the library that you want to access, and that is the output that you want to give it. This means console outs, so it can write something in the console. And this here is to is also a command from the standard library and is endl, and that just means that you wanna end this section here. And it is like, I know it's input buffer, but I have to go into it as well. It just buffs the input that was previously and can lead to longer runtimes because it goes through it buffs the input. But we will come to that later. I need also a broader understanding of this to explain it better. And then if this doesn't fix your issue, then it may be that your compiler is out of date or the install is corrupted. Try reinstalling and or upgrading the latest version of your compiler. So try that, and if it does not work, yeah, just try until it works. And next question, when trying to use endl or end a printed line, the compiler says end1 is an undeclared identifier. Make sure you don't mistake the letter L, lowercase l, in endl for the number 1. Endl is a letter, are all letters. Make sure your editor is using a font that makes clear the difference between the letter lowercase l, uppercase I, and the number 1 is also the letter capital O, or the number 0 can easily be confused in many non-programming fonts. And now the next question. When compiling my program I get a no new line at the end of my file error. The C++ standard requires that all source CPP files end in a new line. It's silly, but it's what it is. Go to the bottom of your files, hit enter, save, recompile. And now, Visual Studio issues. Q. When compiling with Microsoft C++, you get a C1010 fatal error with an error message like C VC project test CPP, that's your name of your CPP, 263 fatal error C1010, unexpected end of file while looking for precompiled headers. That means, like we discussed, you have your precompiled error zone, and now we read what it actually says about it. This error occurs when the Microsoft Visual Studio compiler is set to use precompiled headers, but once more, your C++ code files does not include std AFX header or include pch.h as the first line of the code file. Our suggested fix is to turn precompiled headers, which turn off the precompiled headers, which we show how to do in lesson 0.7, compiling your first program. And they just included those std AFX header and pch.header because they are used when you use precompiled headers, but this is not our business now because we don't want to use precompiled headers. If we would like to keep precompiled headers turned on, to fix this problem, simply locate the files producing the error. Producing the error in the above error test CPP is the culprit, and at the following line at the very top of the files. Yes, you could include it if you wanna left them in your program. Just put this include on top of it, like under include or over include, it doesn't matter, but at the top it has to be. And then older version of Visual Studio use std AFX.header instead of pch.header. So if pch doesn't resolve the issue, try std AFX.header. Yes, and just change that and it should theoretically work. Note that for programs with multiple files, every C++ code file needs to start with these lines. So if you have multiple C CBP files. For example, I can open another one, add a module, and here are more CBP files to add. If you have a new one, you would have to include that here. You would include that here on the top again with your program under it, but we don't use that, so we can delete it again. We can delete that. So we have our normal Hello World CBP and only that. And now the next question. Visual Studio gives the following error: 1M SV etc. error, link 2019 unresolved eternal civil main reference function whatever. It's a lot of code values. You've likely created a Windows graphical application rather than a console application. Recreate your project and make sure to create it as a Windows or Win32 console project. Yeah, that's it could be that you have another graphics API installed on your computer and it does not use the right API and it is not linked to your program, so it could cause an error because it searches for something that is not available right now. And it could fix it if you restart it, but the better if you know how to link it. If you want to use this version, instead, if you want to use the graphical interface application instead of the Win32 for Visual Studio, you would have to link it, but you have to look up how to link this to your project that it works. And now, when I compile my program, I get a warning about cannot find or open the PDB file. This is a warning, not an error, so it shouldn't impact your program. However, it is annoying. To fix it, go into the debug menu, options and settings, symbol, and check Microsoft symbol server. And yeah, just if you have this error, just try that and try to fix it. And like he said, it's an annoying error, so I think it's more to it than he says in here. Something else. Next question. I have some other problems that I can't figure out. How can I get an answer quickly? As you progress through the material, you will undoubtedly have questions or run into unexpected problems. What to do next depends on your problem. But in general, there are a few things you can try. First, ask a search engine. Find a good way to phrase your question and do a search. If you are searching an error message, paste in the exact error message using quotes. Exclude any file names or line numbers. Odds are someone has already asked the same question and there is an answer waiting for you. And if you are giving the exact error into the Google search bar, for example, in this search engine, probably at the start, all the errors that you have will be already have already happened somewhere, and you can look up for them. The more difficult part is then to understand it, what the solution to it is by reading the article, but that's part of the process. If that fails, ask on a Q&A board. There are websites designed for programming questions and answers, like Stack Overflow. Try posting the question there. Remember to be through about what your problem is. And include all relevant information like OS, operating system you're on, what IDE you're using. And probably you will get an answer for it if it's not already there. And now we go to the next lesson, 0.9. Configuring your compiler. Build configurations. Build configuration, also called build target, is a collection of project setting that determines how your IDE will build your project. The build configuration typically includes things like what the executable will be named, what directories the IDE will look in for other code and library files, whether to keep or strip out debugging information, how much to have the compiler optimize your program, etc. Generally, you will want to leave these settings at their default values unless you have specific reasons to change something. When you create a new project in your IDE, most IDEs will set up two different build configurations for you, a release configuration and a debug configuration. The debug configuration is designed to help you debug your program, and it's generally the one you will use when writing your program. This configuration turns off all optimizations and includes debugging information, which makes your program larger and slower, but easier to debug. The debug configuration is usually selected as the active configuration by default. We'll talk more about debugging techniques in a later lesson. The release configuration is designed to be used when releasing your program to the public. This version is typically optimized for size and performance and doesn't contain the extra debugging information because the release configuration includes all optimizations. This mode is also useful to testing the performance of your code, which we will show you how to do later in the tutorial series. When the Hello World program from lesson 0.7, compiling your first program, was built using Visual Studio, the executable proceeded in the debug configuration was 65 kilobytes, whereas the executable built in the release version was 12 kilobytes. The difference is largely due to the extra debugging information kept in the debugging build. Although you can create your own custom build configurations, you will rarely have a reason to unless you want to compare two builds made using different compiler settings. Best practice: use the debug build configuration when developing your program. When you're ready to release your executable to others or want to test performance, use the release build configuration. Some IDEs, Visual Studio, also creates separate build configurations for different platforms. For example, Visual Studio creates build configurations for both the x86 32-bit and the x64 64-bit platforms. And now, switching between build configurations, there are multiple ways to switch between debug and release in Visual Studio. The easiest way is to set your selection directly from the solution configuration downdrop in the standard toolbar options. Set it to debug for now. Here you can see it on the top here. Like we said, you have the 32-bit and the 64-bit version here. You normally also use the 64-bit version that is here on default, and here you can change to release or debug, and we have debug also by default in it. And now you can also access the configuration manager dialog by selecting build menu configuration manager and change the active solution configuration. To the right solution configuration downdrop, Visual Studio also has solution platform downdrop that allows you to switch between x86 32-bit and x64 64-bit platforms. And now we could search for the build menu configuration manager. This should be theoretically, like I think, in the properties. We could quickly look. No, I don't think so. Here is a build. This is just the build when we want to just run the build. Look at that. That's a nice one. Here as this was a task in the previous video that we could not figure out to get that output, but now we have the right one. Here the build started, then it says the project hello world configuration is in debug x64. It's nice to know how to run this, and here you can build it, rebuild it like we had in the previous video that we had to show how this is done. And then it shows you where the folder is and says the build was successful. And here we have the file where it is output, the project file. And we actually don't have an output here, but it's also nice we have an output here as well. I wonder if we run it again, if we have a different time. Yes, we have a faster time right now. If we run it again, let's see. Oh, it's even faster. Yeah, I think this is the maximum. Oh no, it changes once in a while. A little bit, but not too much. From 0.52 to 0.53 or 4. And yeah, it depends how that's from the hardware level, I think, where the code goes in first. And yeah, that's this. And then we have the example for code blocks for GCC, G++ users, then for Visual Code users, and then the next one, modify build configurations yes, wait, we had wanted to figure out how to find the build menu. Maybe we can find it when we go in the build menu. Build solutions, no. That's just the build itself. Like, I try to search the build solution. That should be, no, it's just we just run it when we do this. Rebuild solution, no. It's just build configurations. Wait. Yeah, configuration manager and change active solution configuration. This should be the right one. Configuration manager on build. Yes, on build configuration manager. And then in here you can change to debug release or the other version, and you can do this with the different files that you have in your program. That's nice to know. And now we go back to the website. Now we can go to the modify your build configurations. In the next few lessons we will show you how to tweak some settings in your build configuration. Whenever changing a project settings, we recommend making the change in all build configurations. This will help prevent making the change to the wrong build configuration and ensure that change is still applied if you happen to switch build configurations later. Tip: whenever you update your project settings, make the change for all build configurations unless it's not appropriate for some reasons. And I can show you that if you have the properties here. If you go here and on properties, you can see we have here all configurations, and you can select different things here, and you will not always select all platforms, so you will also do it for all the platforms. Otherwise I don't actually know what could happen, but it can cause some errors like he says. And with that we go to the next lesson, 0.10, and this is configuring your compiler extensions. The C++ standard defines rules about how programs should behave in specific circumstances, and in most cases compilers will follow these rules. However, many compilers implement their own changes to the language, often to enhance compatibility with other versions of the language, C99 for example, or historical reasons. These compiler-specific behaviors are called compiler extensions. Writing a program that makes use of a compiler extension allows you to write programs that are incompatible with the C standard. Programs using non-standard extensions generally will not compile on other compilers that don't support those same extensions, or if they do, they may not run correctly. Frustratingly, compiler extensions are often enabled by default. This is particularly damaging a few learners who may think some behavior that works is part of official C++ standard, when in fact their compiler is simply over-permissive. Because compiler extensions are never necessary and cause your programs to be non-compliant with C++ standards, we recommend turning compiler extensions off. Best practice: disable compiler extensions to ensure your programs and code practices remain compliant with C++ standards and will work on any system. And now disabling compiler extensions. For Visual Studio users, to disable compiler extensions, right-click on your project name in your Solution Explorer, Windows, then choose Properties. That's what we did before. I quickly read further. From the project dialog, first make sure the configuration field is set to all configurations up here. Then click C++, Language tab and set conformance mode to yes. And permissive, yes, permissive minus if it is not already set to that by default. And we quickly look at that. If we have that, we go on our Hello World project and then go to C++ and look here. I quickly look where it exactly was. We have to go on language and then we have here yes permissive minus. Yeah, that's good for us that we have that already. And then the same for the code block users. We don't need that. The GCC user, they have to type in the command, and then Visual Code users have to do something different. And then related content, Xcode users can refer to Roxy's comment, who kindly provides instructions, so they have something else. And a reminder, these settings are applied on a per project basis. So if you make a new project, you have to make sure it is set on this setting that it is right now. You need to set them every time you create a new project, yes. Or create a template project with those settings once and use that to create new projects. That's another option too, yes. But if you do that, you maybe have a problem once because you don't set it to that once, and then it remains false, and then one time you get an error and you don't know what the error makes. And if you do it each time, you just know it. It's just a part of the process at the beginning and you get used to it. And with that we can go to the next lesson, 0.11. Here we have configuring your compiler warning and error levels. When you write your programs, the compiler will check to ensure you followed the rules of the C++ language, assuming you have turned a compiler extensions as per lesson 0.10, configuring your compiler extensions. If you have done something that definitely violates the rules of the language during compilation, the compiler will emit an error, providing both line number containing the error and some text about what was expected versus what was found. The actual error may be on that line or on a preceding line. Once you've identified and fixed the erroneous lines of code, you can try compiling again. In other cases, the compiler may find code that seems like it might be in error, but the compiler can't be sure. Remember the motto, trust the programmer. In such cases, the compiler may opt to issue a warning. Okay. Warnings do not halt compilation, but are notices to programmer that something seems amiss. Best practice. Don't let warnings pile up. Resolve them as you encounter them, as if they were errors. Otherwise, a warning about a serious issue may be lost amongst warnings about non-serious issues. In most cases, warnings can be resolved either by fixing the issue the warnings is pointing out, or by rewriting the line of code generating the warning in such a way that the warning is no longer generated. In rare cases, it may be necessary to explicitly tell the compiler to not generate a particular warning for the line of code in question. C++ does not support an official way to do this, but many individual compilers, include Visual Studio and GCC, offer solutions via non-portable #pragma directives to temporarily disable warnings. And now increasing your warning level. By default, most compilers will only generate warnings about the most obvious issues. However, you can request your compiler be more assertive about providing warnings for things it finds strange. Best practice. Turn your warning levels up to the maximum, especially while you are learning. It will help you identify possible issues. For Visual Studio users, to increase your warning level, right-click on your project name in the Solution Explorer window, then choose Properties. And now, like before, from the project dialog, first make configuration fields to set all configurations, then select C General tab, and set warning level to 4. And we quickly do that. We are still in this. We have all configurations on. We go to General, it says. Wait quickly. Yeah, but from C. Here we have to go, and then we have here the warning level, and we change that to warning level 4, and we click OK. Now we can go back and read along. Note, do not choose enable all warnings, or you will be buried in warnings generated by the C++ standard library. Visual Studio disables signed, unsigned conversion warnings by default, and those are useful. So if you are using Visual Studio 19 or newer, let's enable those. From C++, command line tab, under additional options, add /v44365. This tells the compiler to enable signed unsigned conversion warnings at warning level 4, which you enabled above. That means when we go here into properties and then general, we have here, let's see what it exactly says, from the C+ command line tab under additional options, command line. Is this right? Command line tab, additional options at this. I quickly have to look if it's made here, and no. Wait quickly. Under additional options, yes, it should be here. So we enter it in here, and we quickly paste that, Control C, and then Control V, and we say OK, and we have added this to it. And now we have another from C++ external include tab. Set external headers warning level to 3. This tells the compiler to compile standard library headers at warning 3 instead of 4, so that compiling those headers doesn't trigger this warning. So we go to C++ external include tabs. So we go again here on properties. External includes, and then inherit warning level to 3. External header warning level, and then here the level to 3. Then we can go back, and then it should be fine like he says here. Then it should be no error. The external include tab isn't shown in the graphic above, but appears in Visual Studio Community 19 or newer between the Browse Information and Advanced tabs. See this link, which contains the recent photo of dialog containing the external include tab. So we can try if we get an error or something, and no, it seems we have no issue here. So perfect. And yeah, we can continue here. For code blocks we have the same here, and GCC, and for Visual Studio Code something again, or oh no, this was code blocks. And then treat warning as errors. It is also possible to tell your compiler to treat all warnings as if they were errors. If all warnings, okay. In which case the compiler will halt compilation if it finds any warnings. This is a good way to enforce the recommendation that you should fix all warnings if you lack self-discipline, which most of us do. Best practice, enable treat warnings as errors. This will force you to resolve all issues causing warnings. So we will do that. And for Visual Studio users, it is treat warnings as errors. Right click on your project, name the Solution Explorer window, then choose properties like before. From the project dialog, make first configuration field to set all configurations, and then set C++ general tab, and here general treat warning as errors on yes, and then this should be fine. Let's see if we have that already or not. Then we go on general and we log treat warnings as errors. We change that to yes, and then we have all warnings as errors. So we click OK, and then we can go back. We have the same for code blocks and the other platforms, and with that we can go to the next lesson, 0.12. Then configuring your compiler, choosing a language. Standard. With many different versions of C++ available, C++ 98 03, 11, 14, 17, 20, 23, etc. How does your compiler know which one to use? Generally, a compiler will pick a standard to default to. Typically, the default is not the most recent language standard. Many default to C++14, like we already saw before when we went into it, which is missing many of the latest and greatest features. If you wish to use a different language standard, and you probably will, you will have to configure your IDE compiler to do so. Codenames for in-progress language standards. Finalized language standards are named after the years in which they are finalized. C++17 was finalized in 2017. However, when a new language standard is being agreed upon, it's not clear in what year the finalization will take place. Consequently, in process language standards are given code names, which are then replaced by the actual names upon finalization of the standard. For example, C++11 was called C++1X while it was being worked on. You may still see the code names used in places, especially for upcoming versions of the language standard which won't have a final name yet. Here is a mapping of code names to the final names: C++1X for 11, C++1Y for 14, C++1Z for 117, C++2A for C++20, and C++2B for C++23. For example, if you see C++1Z, this is the symbolism with the C++17 language standard. Which language standard should you choose? In professional environments, it's common to choose a language standard that is one or two versions back from the latest standard. If C++20 is the latest version, that means C++14 or 17. If that is one or two versions back from the latest standard. Yes, okay. If C++20 is the latest version, that means C++14 or C++17. Yes, okay. This is typically done to ensure the compiler makers have had a chance to resolve defects, and so that best practices for new features are well understood where relevant. This also helps ensure better cross-platform compatibility, as compilers on some platforms may not provide full support for newer language standards immediately. For personal projects and while learning, there is little downside to choosing the latest finalized standard as of the time of writing, currently C++20. An author's note. This website currently targets the C++17 standard, meaning our lessons are examples. Assume your compiler is C++17 capable. Some C++20 content is available for those with C++20 compilers. To take full advantage of all the lessons content, we recommend using the C++20 language standard if your compiler supports it. Using the C++17 language standard will also provide a good experience. If your compiler doesn't support C++17, we recommend upgrading to one that does. If this is not possible for some reason, you will need to skip some content and alter some examples so that they will compile. This should not impact your overall experience too heavily, especially in the early lessons. C++14 is the minimum language standard for a decent experience on this side. At the end of this lesson, there are some test programs that you can compile to see if you set up your compiler to use C++17 or C++20 correctly. A reminder, when changing your language standard or anything other project setting, make the change in all build configurations again. And setting a language standard in Visual Studio. As of the time of writing Visual Studio 2022, defaults to C++14 capabilities, which does not allow for the use of newer features introduced in C++17 and C++20. To use these newer features, you will need to enable a newer language standard. Unfortunately, there is currently no way to do this globally. You must do so on project by project basis. Warning: with Visual Studio, you will need to reselect your language standard every time you create a new project. Yes, he repeats it directly again. So every time you make a project, you have to change that ISO version to the new one, so the C++ version. To select a language standard, open your project, then go to Project menu, your application's name properties, then open configurations properties, C++, and then language. And then you can change the language there. So we do that quickly, and now we go to our Hello World program properties. Then we go to our language here in the C++ folder, and then we see here we have our default on ISO C++14 standard. So we look here, we can work at maximum with C++20 on standard, and here we also have a preview feature from the latest C++ working draft. That means it is C++23, but it does not work with all the features. So for the first we take the standard C++17 to try this. Then we go back. First, make sure the configuration is set, all configurations. Yes, we haven't looked at that. That's very important. Do that every time. Here, all platforms, we have that now on default, so it's okay. But always watch out if somehow it changes, or you had to change something and it stays like this. From there, you can set the C++ language standard to the version of C++ to wish to use. We recommend choosing the latest standard ISO C++ latest SD C++ latest, which will ensure you can use as many features as your compiler supports. Make sure you're selecting the language standard from the drop-down menu. Don't type it out. Related content. For more information on the Visual Studio language standard settings, Microsoft has a Visual Studio language standard reference document. Okay, nice to notice. And like he said before, when we go down here on properties again, and here on the drop-down menu, he recommended us to actually take the preview feature from the latest C++ working draft, STT C++ latest. But we stay with the standard for now. I will change that soon, but that I can show you an example when we don't have the latest version on. And yeah, that's my editing tool. I clicked on the wrong page, and here we go further, and this is for code blocks. We don't need that. And now the tip: if C++20 or C++17 appears in this list, select the one that represents the latest ISO standard. Select have G++. Is this still? Okay. This is still from the version of from the code blocks. We go further down. Setting standard Visual Studio Code, and here testing your compiler. Yes, after enabling the C++17 language standard or higher, you should be able to compile the following code without any warning errors. And now we can try this. That was a bit too much. So we can copy that, we make Ctrl C, and then we delete all that and paste our code that we had before in here, and then we run our debugger and let's see, hello 363. That's probably the output that this code gives us, and like you see, it works. And now we go back and we see we have another program here, but first we have this. If you can't compile this code, you either haven't enabled C++17 or your compiler doesn't fully support C++17. In the later case, please install the later version of your IDE compiler as described in lesson 0.6, install an integrated development environment IDE. And now we can test your compiler for C++20 capabilities. After enabling the C++20 language standard, you should be able to compile the following code without any warning errors. And now we can copy that, and this time we don't make Ctrl C, but you can choose whatever you want. Then we can delete that code again, or we can also do, for example, Ctrl Z to reset it, and then we can paste this new code that we just copied in here. And as you can see, we have red lines here, some errors, because this is for C++20, and we can try to start it, but it gives us an error, and there are a lot of errors, and it does not even say that it is a version error. It just say it is an error and it needs a declaration for a lot of things, and it does not have one. And now we can go on our Hello World project on properties. Again, we are already on language, setting this on standard C++20 standard, and click OK, and then suddenly we have no issues at all. And then we have output 6 and 4, that's the output this code gives us, and then we know it works. And now we can continue. I think there is not much more, so I quickly want to do what we previously had to do. So we change our language to the latest version. So we go to for features from the latest version, working draft. So we have all the possibilities that Visual Studio can have for us, and with that this is enabled, and we click OK, and this should also work as before, and perfect. And now we can just make Ctrl Z. We have to go on the file, and then we can go back to the Hello World. If you want to know, if you click Ctrl Z, it will go a step back. Maybe you can see this here. Yes, Ctrl Z here. You can go back, and forward is Ctrl Y, and you could go back to the other code when you deleted it. Back and forth, it's much easier. It's a nice to know command. And then we can go back here, and now exporting your configuration. Having to reselect all of your settings options every time you create a new project is burdensome. Fortunately, most IDEs provide a way to export your settings. This is typically done by creating a new project template with the settings you want, and then selecting that project template when you create a new project. That means basically, maybe it explains it. I go into this comment first. In Visual Studio, this option is available via Project Export Template. Select Project Template, add a name and optional description e.g C++20 console application, and then click Finish. And next time you create a new project, you see this template show up in your list of project templates once you create a new project with this template, it may not open any files. You can open up your CPP file in the Solution Explorer window by going into Solution, Project Name, Source Files, Template Name, CPP. And we can quickly do that. Like it says, you have to go on Export Template and Project Template, and we can, where do we have to go exactly? An option available via Project, Export Templates, and Project Templates. Let's see if we can find that. Project, Export Template here, and change the following. Save change for the following items. Yes, we want to save it. And then template type. It says here, select project template, add a name and optional description. Okay, C++ console application, like it says here. Yes, project template, and then next, template name. Does it say in template name? Yeah, name or optional description. Yes. Okay. We can just quickly copy that here. Copy and then paste it in here. So we have a C++20 console application that will be added here. This document will be in our folder from our Visual Studio. Inside it, my exported templates. It will be in our memory there directly from Visual Studio. And then we can click on Finish, and then it should be there. It's even it's a WinRAR folder that they made. And theoretically, when we start Visual Studio New for a new project, we can go on Templates, create new project, and then we can search for template. Oh, it's already here, as you can see. Our template C++20 console application. We created that, and you can just select that, and then you are ready to go. And when we click on it, we should get our hello world. We can quickly try that. Template test. And when we do that, we just make the folder in our repository, and I can see we have all set like we have made. And now you can see we have no CPP file, but our properties are set like we have set them. Our versions should be the version we want, and we can quickly look that on language. Yes, you can see you don't have to change that now because it's already in here. All the features, normally you have to change that each time, but it's now in it, and all the things you want on here. Yes, permissive that we change, or that was already on default. The level, the treat warnings as errors is also on, and you don't have to do that again. And you know, when you have your template and you click on your template, this is already set, but if you make a new one, you have to do it manually. And that's how this works. And if you want to make a CPP file now with your project, you just add a module. You will probably learn that later, and you can just add it here, a CPP file. You can also add a header file here and other files as well. There are much more, but those use cases we look later into, if even. And then you could add this CPP file and then start your program like you would do in the later in the later lessons. And now you can close that, and we actually don't have to save that, but for now I'm saving that to maybe use it for other examples. Maybe, but for now it's good and we can continue. And this is for code blocks the same. And where can I view the C++ standard documents? Each C++ language standard is described by standard documents, which is formal technical documents, that is the authoritative source of the rules and requirements of a given language standard. The standard documents is not designed for learning, rather is designed for compiler writers to be able to implement new language standards accurately. You will occasionally see people quoting the standards documents when explaining how something works. The approved C++ standards documents for a given language standard is not available for free. There are a link to purchase the latest standard here. So if you wanted current standard, and you can get them here, purchase the C++ official standard, and if you click on it you can get the ISO standard code for the standards, what's behind it, how the code is executed, and you get the compiler code from it. Now we are back on C++.com and we read the last article. When a new language standard is being developed, draft standards documents are published for review. These drafts are available online for free. The latest draft standard before the approved standard is generally close enough to the official standard to use for most purposes. You can find the draft standards here, and we can also go here, and those ones are free to look into, and I would say if you click on this link it is the easiest way to access it, or you can paste this and store it somewhere, and maybe there is something more interesting to watch in here. And yeah, with that we finished our first lesson or first chapter of the learnc++.com website. Yeah, we have a long way to go. We have the first done, but we have how many? 27 more to go, and some additional things that are here. Maybe they're useful, but we will not be there very soon. We have first to go through some other things on this website, but for today I think it's enough. And with that I would say I hope you learned something today or had some fun watching it, and with that I say bye.